Hello everyone, very good morning. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S exam prep. So guys, yesterday we have already discussed some questions related to concept of graph theory. In today's session, we are going to discuss few more questions related to graph theory. So yesterday we were generally discussing the questions in which the statement is defined to define the or statement is given to define the labels of the vertices. Then it was given that how the edge may or may not be present between two vertices based on the characteristic of the labels. Now today we will solve some different type of questions. Okay, so this is brief introduction of myself. My name is Vishal Ravatia. I have 10 plus years of teaching experience. Following are the achievements and areas of expertise. This is my Telegram group. You guys can join this group and can ask any question related to GATE exam, whether it is CS paper or DA paper. These are the announcement. BYJU'S exam prep is going to conduct a national scholarship test on 15th of October between 9 AM to 9 PM, that is tomorrow. Do participate in this test. If you perform good, then you may avail up to 90% off on all our programs. Apart from that, on 18th of October, Dheeraj Sadhana sir is going to conduct a workshop that what will be the right time to start preparing for GATE 2025. So if you are GATE 2025 aspirant, then this workshop is for you. Now, if whether you want to participate in the scholarship test or you want to attend this workshop, you simply need to download the application and register yourself using the name. These things are absolutely free. Now you can download the application from the link given in the description. And guys, if you are preparing for 2024, then it is high time that you start appearing for the mock test or test series. So from tomorrow, BYJU'S exam prep is going to conduct a mega mock test. Do participate in this test. Do participate in that particular mock test. Okay. So this is the very first question, simple question. In a connected graph, a bridge. What is a bridge? A bridge, or I can also call it as line. So a bridge or edge such that the removal of that particular edge from the graph makes the graph disconnected. Then it is called edge or bridge, right? So please try to understand bridge or edge connectivity. So in a connected graph, a bridge is an edge whose removal disconnects the graph. Which of the following statement is true? So every edge of a clique, what is a clique? Given a graph, a subgraph in that given graph such that that subgraph is a complete graph with some vertices. So let's assume there may be 10, 15, 20, any number of vertices in the original graph, but there may be a possibility that 3 vertices are mutually adjacent to each other, or there may be a possibility that 4 vertices are mutually adjacent to each other, and there apart from that there are some other vertices which are connected in some other manner. That's absolutely fine. But do you realize that this is a complete subgraph of this given graph? So complete subgraph of a given graph is called clique. Clear? Okay, so which of the following is true? Every edge of a clique with size greater than or equals to 3. So if we are saying that clique of size greater than or equals to 3 means the subgraph is K3 or greater than 3, or I would basically say subgraph is Kn such that n is greater than or equals to 3. If you have a subgraph which is equivalent to a complete graph such that the number of vertices in that subgraph are greater than or equals to 3, then no edge of that particular subgraph can be a bridge. Why? Because in K3 or in any other complete graph Kn where n is greater than or equals to 3, all the vertices are connected with each other, or because they are actually mutually adjacent to each other. So even if you delete one edge, then also using some other path, they will be connected with each other. Now, apart from that, in complete graph K3, there will be a cycle, and in any complete graph K4 or greater than K4, if you take any three vertices, then those three vertices will eventually form a cycle with each other. Got the idea? So this is the logic, that there will be a cycle if there are three or more vertices. Now, if you delete any edge from a cycle, it cannot be a bridge. So the idea is, the edge of a cycle can never be a bridge. The edge of a cycle can never be a bridge. So here it is saying every edge of click is a bridge. No edge of click is a bridge. So option A is false. A tree has no bridge. Now again, it's complementary. In a tree, it's a barely connected. Tree is a barely connected graph. So if you remove any edge from the tree will become disconnected. So it says a tree has no bridge, but precisely every edge of a tree is a bridge. So this statement is also false. You can take any tree. So let's assume that this is your tree, right? Try removing any edge and this graph will become disconnected. Let's assume if I remove this, then this will become one component and this will become another component. Now, a bridge cannot be part of a simple cycle. Yes, I just told you that there is a cycle. Now, if you remove this, then this two will be connected via this particular path. If I remove this, then they will be connected via this particular path. If I remove this, then they will be connected via this particular path. So in a cycle, if you remove any edge, so in a cycle, there will be at least two different paths. In a cycle, there will be two different paths between every pair of vertices. So even if you break one, even if you delete one edge, then one path may be broken, but still another path will still be available, and hence the graph will remain connected. So a bridge cannot be part of a simple cycle, obviously. So this is the correct statement. A graph with bridge cannot have cycle. No, it's wrong statement. Please try to understand. If I connect this to, or let me draw a new one. So this is a cycle. Now let's do this. In this particular graph, I hope you realize that if I delete this particular edge, then this will become one component and this will become another component. So a graph with bridge cannot have a cycle, sir. This is a bridge because the removal of this particular edge from the graph makes the graph disconnected. So the bridge exists in this particular graph, but the cycle also exists in this particular graph. So a graph with a bridge can also have a cycle. There is no such restriction. Therefore, option D is false. Let's move to the next question. A graph is self-complementary. Please, a graph is self-complementary if it is isomorphic to its complement. Now, for all self-complementary graph on n vertices, what should be the value of n? So, it's a generic statement. Please try to understand. Because we are saying the graph is self-complementary. So, if I say the graph is G, and if we define the complement of graph G as G bar, then if we are saying that the graph is self-complementary, then graph G will be similar to its complement. That means graph G will be isomorphic to its complement. Self-complementary, so it is defined that if it is isomorphic to its complement. So if G is your graph and G bar is the complement of that graph, and if these two are isomorphic to each other, then G will become self-complementary. Now in this particular case, please try to understand one thing. If the graph is a simple graph, if the graph is a simple graph, then only this definition will be true. Why? Because complements can be defined only for the simple graph. Now, by the definition of complement, what do we know? That number of edges in graph G plus number of edges in graph G bar. By the definition of complement, number of edges in graph G plus number of edges in graph G bar will be what? So please try to understand. If you take the union of G and G bar, if you take the union of G and G bar, then it will be a complete graph with n vertices if G and G bar are the graphs with n vertices. Clear? So let me give you an example if you don't understand this. So let's assume that this is my G. What will be a G bar? So G bar will be a graph with same vertices as of G. So take the same vertices, and edge will be present if and only if that edge is not present in G. So this edge is not present in G, so it will be present in G bar. This edge is also not present in G, therefore it will be present in G bar. This edge will also be present in G bar. If you take the union of these two, what will you get? Sir, if you take the union of these two, then ultimately you will get a complete graph with 4 vertices, right? If G is a graph with 4 vertices, G bar is guaranteed to be a graph with 4 vertices. If you take the union, you will get the complete graph, sir. So the edges are mutually exclusive. The edges are mutually exclusive. That means the edges in G and G bar are disjoint, and they together form all the edges of a complete graph. Therefore, the number of edges in G plus number of edges in G bar has to be the number of edges in a complete graph with n vertices. That is nothing but n into n minus 1 by 2. That is nothing but n into n minus 1 by 2. So this is the observation by the definition of complement. Now please try to understand, because G and G bar are isomorphic. So two graphs are isomorphic if and only if they are having the same property. So if they are having the same property, then the another thing which we know from the isomorphism is that number of G, or the number of edges in G, will be equals to number of edges in G bar, because the number of vertices, number of edges, adjacency, that all should be same for two graphs to be isomorphic. So number of edges in G will be equals to number of edges in G bar. If I have used this two equation, this, let's say that this is my equation 1, this is my equation 2, then in equation 1, from equation 2, you can represent number of edges in G bar using number of edges in G. So this will also become number of edges in G, right? So 2 times the number of edges in G, 2 times the number of edges in G will now become n into n minus 1 by 4, n minus 1 by 2. So number of edges in G will become what? So number of edges in G will become n into n minus 1 by 4. N into n minus 1 by 4. Now please try to understand, if the graph is self-complementary, then the number of edges in G, will be equals to n into n minus 1 by 4. And we know that in a graph, the edges cannot be fractional edges. A number of edges will always be perfect integer. Therefore, this n into n minus 1 by 4 must be an integer for this graph G to be self-complementary. Now the idea is n into n minus 1 by 4 can be integer only if either n is divisible by 4 or n minus 1 is divisible by 4. So if we say n is divisible by 4, means n should be multiple of n should be multiple of 4. Come on. N should be multiple of 4. So this k may be any random value, or n should be, n minus 1 should be multiple of 4. So n minus 1 is multiple of 4 means n is multiple of 4 plus 1. N is multiple of 4, that is 4k, some 4k times plus 1. So the value of n should be either multiple of 4 or multiple of 4 plus 1. Now what's the idea? If the number of vertices are multiple of 4 or multiple of 4 plus 1, if we divide it by 4, the remainder will be either 0 or 1. The remainder will be either 0 or 1. And that's what is being defined by this option D, that the number of vertices, that is the value of n, is congruent. Value of n is congruent to 0 mod 4 or 1 mod 4. That is, on dividing by 4, the remainder will either be 0, or on dividing by 4, the remainder will either be 1. Clear? So, multiple of 4 is also okay, but it is not the most precise answer. Among A and D, the most precise answer will be option D. Clear? So, that's okay. So, remaining 3 are false. So, please try to understand that this equation is something which, if you do not already know, it will be very difficult to derive it while sitting in the examination hall, because those many things may not come in your mind while trying to solve this type of question. So please remember this equation, that whenever G is a self-complementary, the number of edges in G will be n into n minus 1 by 4. Some other types of question can also be formed on this particular equation. We'll see. Okay, now G, next question, G is undirected graph with n vertices. Okay, there are n vertices. The number of edges are also given, 25 edges, such that each vertex, each vertex has degree At least 3. Now in our graph, if the degree of every vertex is given as at least, right? So if in our graph G, if the degree of every vertex is at least k, then we say k mod v will be less than equals to 2 mod e. Here it is given that the degree of every vertex is 3, therefore 3 mod v will be less than equals to 2 mod e. Okay, sir. So that's one equation which we know from this statement, right? So that's a corollary. Now it is asking for the maximum possible value of n, the maximum possible value of n. So this is our graph. So mod v value is actually n, mod v value is actually n. So 3 into n has to be less than equals to 2 times the number of edges. How many edges are 25 edges? 25 edges. So this is a very simple question actually. The value of n has to be less than or equals to 25 by 3. So it will be something 16 point some value, 16 point some value x, which is non-zero. So please try to understand, n has to be less than or equals to 16. So the number of vertices should be less than or equals to 16 point something. So what is the maximum possible value of n? The value of n can be 16, 15, 14, etc. But the value of n cannot be 17. The moment the value of n becomes 17, the degree of every vertex will not remain at least 3. Okay, some of the vertices will eventually have degree less than 3. Clear? So that's the logic. So the correct answer for this particular question will be 16. Clear? Let's move to the next question. Next, in an undirected connected, okay, so now it is related to planar graph. It is an undirected graph. And what type of undirected graph? It is a connected planar graph. Now, please try to understand, in a connected planar graph, a very important definition holds true, that is Euler's equation, Euler's observation, which says number of vertices in a graph plus the number of regions in that graph will always be equals to number of edges in that graph plus 2. So this is known as Euler equation. This is very famous equation with respect to planar graph. In the concept of planar graph, if you want to learn anything in the planar graph, this equation is there in front of you. So in an undirected connected planar graph, this equation will hold true. There are, now what is being said, there are 8 vertices. Oh, number of vertices are given as 8 and 5 faces. The regions are also known as faces. Regions are the regions of the plane. Basically, your connected graph divides, or your planar graph divides a plane into connected areas known as regions, or you can say that those are nothing but the faces of your planar graph. So same term that some author may use it as mod v plus or v plus f or n plus f equals to e plus 2, but it's about the different authors, nothing more than that. So 8 plus the number of faces are 5, number of faces are 5, it is also given. Now mod e plus 2. Then it is asking number of edges. So number of edges will be 11. Number of edges will be 11. Damn easy question, but the only thing is, now what's the logic? Sir, please remember this equation also, and please try to understand. If somebody tells you that it's a connected planar graph, if somebody tells you that is a connected planar graph, then we know that this thing will hold true. Now, apart from that, some other things like this, that the degree of every vertex is at least 3, something like this may be given. So if something like this is given, then you can eventually use 3 mod v is less than equals to 2 mod e. 3 mod v is less than equals to 2 mod e. So 3 mod v less than equals to 2 mod e. So either you can replace mod v by mod e, or you can replace mod e by mod v. So you will be able to derive some other relations between mod e and mod r, or mod r and mod v. So that's the logic, that you can convert one thing into another by analyzing the different things. So I mean, the simple reason of discussing this is that you must know this Euler equation. Okay, next question. A cycle on n vertices. Again the question of isomorphism. Again the question of isomorphism. A cycle on n vertices is isomorphic to its complement. So basically what is being said is a cycle of n vertices is isomorphic to its complement. What will be the complement? Sir, complement will be Cn bar. Now it is asking that what will be the value of n? What will be the value of n? If you randomly start drawing the cycle graphs, then it will be just a wastage of time. Please try to understand certain things. We are discussing discrete mathematics. So if there are equations available for some concepts, then those equations will be very helpful in identifying the answers in less amount of time. Yes, obviously in discrete mathematics, logical thinking aptitude is also required, but at some places when the equations or when concepts are available to solve those type of questions, please try to utilize them. If you generally try to draw the different cycle graphs with different number of vertices, and if you try to convert them into their complement, then it will be time taking. But please try to understand, what do we know from our basic concepts? Sir, the number of edges in a cycle graph Cn in general, how many edges are there in a cycle graph Cn? Sir, in a cycle graph with 3 vertices, there will be 3 edges. In a cycle graph with 4 vertices, there will be 4 edges. In a cycle graph with 5 vertices, there will be 5 edges, etc. So the number of edges in a cycle graph with n vertices will be n. That's equation 1. Now, please try to understand. We have just derived one equation where we say that if the graph is self-complementary, then the number of edges in that particular graph will be exactly same as n into n minus 1 by 4. Now, the same logic, because Cn is a self-complementary, what do we know? Because of self-complementary property, the graph which you are talking about, that is the cycle graph Cn with n vertices, should have exactly n into n minus 1 by 4 edges. It cannot. If the graph G is a self-complementary graph, then the number of edges will be exactly n into n minus 1 by 4. Will be exactly n into n minus 1 by 4. So please try to understand the cycle graph Cn. Both of them are the same graph, but there are two different variations for the number of edges. So this two should be same, because we are talking about the same graph. Therefore, by 1 and 2, I can actually say that n has to be equals to n into n minus 1 by 4. If you solve this equation, you will get the value of n as what? Sir, the value of n should be 0 or 5. If you solve this equation, the value of n should be 0 or 5. So what should be the exact value? Sir, with n equals to 0, it is not a graph, it's an empty graph. With n equals to 0, it is not a graph, it's an empty graph. There is no complement for that, there is nothing defined for that, right? So what will be the exact value? So the value of n has to be 5, or the cycle graph with 5 vertices, is self-complementary. If you were trying to solve this question by constructing the graph, then please try to understand. This is very, by looking at this, it doesn't seem that the complement of this will eventually be isomorphic to this. But please try to understand what will be the complement of this graph. Sir, all these peripheral edges are present with respect to cycle, but the edges which are not present in this graph are this are the edges which are not present. Yes or no? Otherwise, if you use this, already present. already present. So these two are the graph. So if this is your C5, then this is your complement of C5. Do they look same? Do they look isomorphic to each other? So generally, I mean, your mind may not give you the intuition that C5 will be complement to a C5 will be isomorphic to its complement by looking at this graph. But if you closely observe, the mathematical formula cannot give you the wrong answer. So the idea is, if you stretch is in this particular direction, after that if you stretch is in this particular direction, then you will start feeling that okay, yes, it is like a cycle. Okay, so let's do that. Leave it. I don't want to get indulged into this. Let's give them the name 1, 2, 3, 5. Now, where exactly those vertices are present, it is not important. So let's assume that this is 1, 2. If I bring 4 this side, then ultimately 4 is adjacent to 1 and 2. Now the idea is 5. Let's draw this 5 this side. And Let's have 3 as it is. 3. Now, what's the idea? So, 1 is adjacent to 3 and 4. So, already adjacent to 4. So, let's make it adjacent to 3. 2 is adjacent to 4 and 5. 2 is already adjacent to 4. Let's make it adjacent to 5. Now, 3 is adjacent to 1 and 5. 3 is already adjacent to 1. Let's make it adjacent to 5. 4 is adjacent to 2 and 1. Yes, already done. 5 is adjacent to. So, do you realize that now it looks like a cycle? Now it's look like a cycle with 5 vertices. So, it's the logic. I mean, directly it may not be it may not make sense that, yeah, the C5, complement of C5 is isomorphic to C5. But if you observe closely, yes, they are isomorphic. Anyway, so these are some simple concepts. Please try to understand. We have solved some questions of graph theory in the yesterday's class. Today's and the questions which I have considered in the today's session are comparatively easy. But tomorrow we are going to discuss some damn difficult questions of graph theory. So it is not so that only easy questions are framed from the topic of graph theory. Some complicated questions can also be framed from the concept of from the topic graph theory. So you all need to be ready for all type of situations. Now, if you realize that what actually is the scenario, so these are the questions which the GATE organizing institutes have asked from the graph theory in the year 15, 16, 17. So these are the questions from 15, 16, 17 and all of them are easy, right? 14, 15, 16, 17. So please don't make any assumption that the questions will be of this type only. Therefore, in tomorrow's session, I'm going to come up with some tricky questions in which you will have to struggle a lot with the question. So that type of question will also be there. So we'll discuss them in the tomorrow's session. Till then, take care, keep learning, have a good day.